Good. And I want everybody to please, and I'm going to share screen with you right now. And let's see what happened there. We're going to go here. And then we're going to go up there and participants. Move that down. And okay, hold on one second, guys. I'm having trouble with the little cursor guy. And there we go. Somebody's making noise right now that they need to stop. That's kind of important. Really appreciate it. Now, can everybody lower their hand, please? And we are going to get started. So I want everybody right now to go to page 1 in their packet. Everybody go to page 1 in their packet. And when I look at page 1, what is the first word on the top of the page? What is the first name of this shape on the top of the page? Who can answer that? And I'm going to actually lower all hands because some people didn't know how to do that. And if you raise your hand, I'm going to call on you if you know what that says. And I'm going to make it a little bit bigger. And Brennan, why don't we start with you, buddy?
You gotta move
A triangle.
And how many sides, can someone else tell me how many sides has a triangle? Who can answer that question? Aiden?
3.
Great. And now, can you find a triangle in this picture? Who can find that?
Yes.
And who, and Signe, go ahead, Signe.
I think it is here.
Well, this is a figure, Signe, that has 20 sides. 1, 2, 3, 4, and I could keep going. 5, 6, 7, 8, 9, 10, 11, 12. So that has way more than 3 sides. But that was a really, really good guess. Thank you for trying. Can someone else raise their hand and try that one? I am really looking. Amelia, go for it.
Okay.
Go
It's
ahead, Amelia.
right on the bottom, so small.
Oh, Amelia, did you find it here, here, and here?
Yeah.
Now, who could name each of those red points? And before you name them, I want to ask you guys a question. Can you please tell me, when you go into a big building and you walk into the building, do you first have to choose an elevator? Or do you first go to like the 11th floor? Do you first go to the 11th floor and then choose an elevator? Or do you first choose an elevator, you walk into the elevator, and then you hit the number 11? Which one do you do first? Who can say?
Elevator.
Hannah, what do you think?
They use the elevator, then press the number 11.
Well, I totally agree with you. Now, let me ask you this question. What elevator should we choose to name these 3 dots? Let's choose the dot that's up here on the top, and that dot is called a vertex. Can everybody say the word vertex?
Vertex.
Yes. Can somebody tell me which elevator I will have to choose? Anyone can say the elevator. Anyone can name that elevator. Go ahead.
1.
Of course. And we write down 1 is the first number that comes after this little arc we call a parenthesis. And I want you to write that down and put a little comma. And then if I'm looking for this vertex, how many floors up do I have to go? How many floors do I need to go up to get that point? Who thinks they know?
Go up, how much?
Because I need to write that number in the next place. Who can tell me? And I am gonna choose, I'm gonna choose Aiden. Go for it, Aiden.
I don't know.
So Aiden, are you looking at how high I have to go? What floor would that be, Aiden?
2.
Well, if I went up 2, I would end up
Where's our hat?
over here, Aiden.
Yeah.
First elevator, second floor, but I don't want to be there right now. I want to be right here. Raymond?
The first floor. 1.
1, of course. We have to go to the first elevator and the first floor. Now, the next one is going to be really, really challenging.
别再讲了。
I want you to tell me what is the location of the next black vertex. And actually, you know what? I'm going to make that vertex purple. I'm going to make that vertex purple. You can tell me the coordinates of that particular vertex. And I'm going to call on Jeremy.
He says in the first lesson.
Jeremy, which elevator is it, buddy?
What'd you say?
Which elevator is the purple vertex?
One living to the second floor. Or it's going straight up.
And Jeremy, would you like some help, buddy?
Sure.
Okay, Signe, can you help us out? Go ahead, Signe.
I think it's 0.
So you think the purple elevator is 0? What do you think the purple elevator is? Who can say that out loud? Angela?
1.
Yes, it is 1. Now, Signe, if you were in the elevator, what button would you push? Do you have to go anywhere?
Not be completed as dialed. Please check the number and dial again.
Yeah, whoever's computer is doing that, if you could make sure that that doesn't happen, that would be awesome. And guys, how many floors up do we have to go? But you have to use a number. You can't say no floors. You have to use a number.
0.
Who said 0?
0.
Everybody write a 0 right now. Everybody write a 0. Oh, wow. Now,
A 0 way on.
now I have the biggest challenge yet. The biggest challenge yet is for you to name the red vertex. And it is a really big challenge because have you ever been inside an elevator with a number like that?
小一点儿。
What number would you use? Raymond, do you have an idea? And Brennan, you have your, what about you, Brennan? Do you have an idea what elevator that would be called?
0.
Oh my gosh. Yes, everybody, round of applause. That was beautiful work. Now, I got into the 0 elevator. What button should I push?
0.
Guess what? I'm just gonna push 0.
啊
And guess what? That-
0.
and do you guys know that that point has a special name? Would you guys like to know the special name of that point?
Yep.
It is called the origin. Can everybody say the word origin? The origin is 0.00. Really awesome. Now, I want someone else to tell me what is the next size polygon after a triangle. Triangles have 3 sides. What kind of polygon has 4 sides? Can anyone name it, please? And if you can name it, say it out loud right now.
Square.
Ah, a square,
Rectangle.
well, a rectangle, a square and a rectangle are special types of, everybody say this word, quadrilateral.
Quadrilateral.
So everybody go like this with their hands. Quad, quad means 4, and lateral means sides. Everybody go. Quadrilateral, quadrilateral, quadrilateral. And the quadrilateral here is called a what? What's the quadrilateral that I drew for you? You can say it, Angela. And Angela, you may want to unmute yourself so when you raise your hand and I call on you, you can answer right away. Now, guys, let's look at the next one. If it has 5 sides, it's called a what?
Pentagon.
If you say it, you have to show me. Come on. Pentagon. Pentagon. And then 6 sides. 6 sides.
Hexagon.
Everybody go like this. Hexagon. 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 Now, what about 7? It's either a hepta or a septa. Can you say hepta? And now say septa. Now, I want to give you something to think about. Does septa sound like another word, like maybe a month of the year?
Oh.
Brennan, what do you think?
September.
Yes. So a septagon has 7 sides, but September is what month of the year? Does anybody know?
9.
It's definitely the 9th month. And everybody always is a little bit curious about why that is. So I'm wondering if anybody knows why did September get moved from month 7 all the way to month 9? What happened in between? Does anybody know? It's a wonderful story. And Roman, could you take the pencil out of your mouth? I'm just worried that if you fell, you could hurt yourself.
August. And July.
Oh, yes. So August. And what month comes before August?
July.
And guess what? There were 2 Roman emperors who decided to name a month after themselves. So the July was somebody called Julius Caesar, and the August was Augustus Aurelius. And so they messed up everything. September used to be the 7th month. And then these 2 crazy emperors said, I want a month named after me. Can you imagine if Mr. Kramer was the president of the United States and said, I want a month to be named after me. The first month of the year is called Kramer Math Month.
What's it called?
Would that make 13 months of the year?
No.
Yes, that would be very, very strange. Very, very strange. Now, who knows an 8-sided figure? 8-sided. Say it out loud, Declan.
Octagon.
And guys, remember, October used to be the 8th month, but then got moved back, and now it's the 10th month. Now, 9 is not very well known, but it's called an enneagon. And I also know that it can be referred to as a nonagon. And if you think of the month November, that used to be the 9th, but is now the 11th month of the year. So who can find the nonagon in this picture? Who can find the nonagon? And then we'll count to see if you're right. Who can find the nonagon? And I'm going to go with Jeremy.
The nonagon is the one that has a 9 in the middle.
Wait a minute. So should we be able to count the sides, Jeremy? Everybody help me. Go.
1,
1,
2, 3, 4, 5, 6, 7, 8, 9.
and it works. Now, before we leave this page, everybody, I just want to ask you, do you think that my quadradecagon looks like a dog?
Yeah.
Does my quadradeca, by the way, quadradeca is 14. Do you think that my dodecagon, which is 12 sides, do you think that looks a little bit like a what? Wait, Amelia, what do you think it is?
Crocodile mouth.
Oh, I think it definitely looks like a crocodile. Who can tell me
Now.
about my 11-sided one?
It looks like
What do you think, Roman?
it looks like a ninja throwing star.
It does? It does? Does anybody else see anything, Hannah?
It looks like a dog burying something.
You know, I like that. Anybody else? Just say it out loud if you have an idea. Go ahead.
dolphin.
Why?
What did you think?
The 10th is a bird.
Oh, I totally agree. Some people think my bird looks like an airplane. And I don't really know what my 20-sided, that's called an icosagon. But if anybody wants to try to figure out.
I know what the 18 is. The
Wait,
18 is a person laying down.
Like a helmet.
Oh, a helmet. Roman, you are correct. It does look like the helmet of maybe a football player. Oh my gosh. Guys, I hope that you create your own polygons this week. Now, everybody go, if you could, everybody please go to page 3. Everybody go to page 3. And if you have a color printer, you will see that I have colored in every one of these quadrilaterals. And there's only one figure here that is not a quadrilateral. Who can name the one figure that is not a quadrilateral? Who can name that? Roman, go for it.
The square.
Well, the square has, let's see, 1, 2, 3, 4. Yep. Roman, the square is definitely a quadrilateral because it has 4. But that was a good try. Amelia?
Triangle.
Oh my God. Did anybody else see that this isosceles right triangle is only a three-sided? Can anybody tell me why it's called a right triangle? Yes, Roman.
It looks like a blue diamond, and that has 4 sides.
Yes, this is a four-sided called a rhombus. We're going to talk about that in just a second. Who can tell me why this triangle is called a right triangle?
1, 2, 3.
Aaron, can you tell me why?
4.
Aiden can tell me why, but Aiden, I can't see you
I
anymore.
found the frame.
And Roman, raise your hand, buddy. Aiden, go ahead, buddy.
The next one is called a kite.
Yes, it is, but can you tell me why this triangle is called a right triangle? Who can do that? Who can tell me why it is called a right triangle? Go for it, Raymond.
Because it just, if there is a square, it'll fit into the right side, right corner of the square.
Oh my God, guys, are we gonna test what Raymond just said? Guys, did that right triangle fit right perfectly into half of the square?
Yes.
Wow.
Yeah.
Raymond,
Yeah.
that was wait a minute. Did we just now create all quadrilaterals? Every single one of our figures is now a quadrilateral. So now, Roman, you mentioned something about the rhombus. You called it a diamond, but it's not a diamond.
3, 4.
Yes. Who can tell me what is special about a rhombus? Rhombuses have something.
Sideways diamond.
Well, it's not a diamond. If you ever look at a diamond, like for instance, let's say that your mom has a diamond, let's say a ring, you may look at it and it's not going to look like this picture. So
Doesn't look like.
mathematicians, for some reason, don't use the word diamond. Teachers do, unfortunately, but this is not a diamond. This is called a rhombus, but you have to tell me why.
Rhombus.
Hannah, do you have an idea why?
No, I was just stretching.
Okay, so who's going to raise their hand and tell me what's special about this rhombus? And Aaron, I want you to move forward so you can really look at it. Is there something going on here? Jeremy?
It's a sideways diamond.
Well, it's not a diamond, but there's something special about it. And we need to talk about what's special about a rhombus. Guys, is this red side the same distance as this red side?
Yes.
The same distance as this red side,
Yes.
which is the same distance
Yes.
as that red side.
Yes.
So
Yes,
what can we
yes.
say about a rhombus?
Blah blah blah.
What can we say about a rhombus?
Oh, yes.
That it has all equal sides. And we can even make little pictures, everybody. Look at the little pictures, and I want you to make those on your rhombus. Make 2 little dashes going on each side, and that shows that the rhombus has equal length. Did everybody do that?
Yeah.
Now,
Yeah.
I want you to go to the rectangle now. Who can tell me what is special about the rectangle? There's something really, really special about the rectangle. And go ahead, Jeremy. And Hannah, if you want me to call on you, you have to raise your hand electronically, please. Jeremy?
The sides are not equal.
Ooh, I agree with you that the red sides are not equal to the blue sides, but Hannah's going to tell us something else. Go for it, Hannah.
So I was gonna say the same thing. The rectangle doesn't have equal sides.
Well, wait a minute. It can. This one does not. But guys, aren't the red sides the same length?
Yeah.
Yes? Well, the red sides are the same length. What about the green sides? Are they? Oh, wait a minute. So guys, we know that rectangles have a very, very special quality because their opposite sides are equal. But there's one more thing. And Aiden, why don't you tell us what else is special about a rectangle?
It can turn.
Oh, Roman, you can't make that noise in the middle of our class because everybody can hear that. Go ahead, Aiden.
Because it can turn into two squares if you cut it in half.
You know, I would think that it definitely gets pretty close to two squares. Not this one, but others can. But what is so special, guys, about each of the angles? Look at the angles, everybody. Make that angle with your hand. Make that angle with your finger and your thumb, your forefinger and your thumb. And everybody say right angle.
Right angle.
Now, everybody do the same thing with their elbow.
Right angle.
And now everybody do the same thing with their knee and their leg. Ready? It's a right angle. It's a right angle. That's right. Now, don't get hurt. Don't get hurt. Now, do we see any other right angles? I see a right angle. Guess what I see? This piece of paper. Does each vertex have a right angle? Why don't you pick up a piece of paper and show me your right angle?
This is a right angle.
And what else can I do? Oh, look at this, guys. I just found a credit card, and this has a right angle. And what else? Oh my God, look what I just found.
Computer.
I just found oh, computer. I just found a book with right angles. Oh my God, who found a chess set? Aiden found a chess set. Signe found a pencil case. Jeremy found a mask. And Amelia is actually making right angles with her fingers.
Use this finger and this finger, and this one is the same. Then put them together, then make them like this.
Oh my God, that's so hard to do. And I love the fact that, oh my God, Roman has a credit card and paper. Everybody's doing it. Now, guess what, guys? Everybody look at the page. If you took a rhombus and a rectangle and put it together, what would you get?
Oh, square.
Yes. So everybody, if you take a rectangle which has 4 right angles and you take a rhombus which has 4 equal sides, you get a square. Now, can anybody tell me what is interesting about a kite? Everybody look at the kite, and it's Mr. Kramer's favorite shape because I love to kite surf and I use a kite all the time, but this is a mathematical shape called a kite. Hannah, what do you see?
Like there's sides that are short like this on the top, and there's sides that are long like that. And the short sides are more like planted than the other one.
Ooh, you know, Hannah, that was a beautiful, beautiful observation. And Raymond, don't make that noise because everybody can hear it. Who can tell me about the red sides? Do you see something that they have in common? Does anybody know? Go ahead, Declan. No, Declan, you're muted, Declan. You've got to unmute yourself, buddy. Keep yourself unmuted. There you go.
They both have this.
The word "this" is
Oh!
very hard for me.
They
The-
both have equal thing.
Yes, they are equal in size, everybody. The reds are equal. Who can tell me about the blues? Raise your hand if you can tell me about the blues. Signe?
They're also equal.
Yes, but aren't they different and equal? So they're different than the reds, but they're equal to each other. Who can tell me something special about what happens when we connect something called the diagonals? Inside the kite, we have something called diagonals. What happens inside the kite? Anybody that can name it right now, go. You can just say it if you understand it.
If you cut it in half, it'll make a triangle.
Oh, that's true. But what happens when you draw the two diagonals, diagonal 1 and diagonal 2, what do they form? What kind of an angle? Everybody go like this with their fingers. Everybody go like this. Does it form a special angle? What kind of an angle does it form, everybody?
Right.
It's called a, say it out loud. Everybody say it. Right angle. Oh, Roman, can you show us that that sticky note again? Because Roman was showing us a sticky note that had a beautiful right angle. Really, really nice.
I
Oh,
have
you know
a
what's
right
really fun to do, guys? If you have a sticky note, you can draw a diagonal and then draw the other diagonal. And look what happens. If you draw the two diagonals,
Makes it
they form a right angle. So not only kites, but rhombuses also have a right angle in the middle when you create their diagonals.
Look.
Now, I want everybody to go to page 2 right now. Everybody go to page 2. And on page 2, I want everybody to draw their own square. Now, I'm going to draw a square after you start drawing your own. So go ahead and draw a square. And remember, a square has to have 4 right angles and 4 equal sides. So draw a square. Like I'm going to choose one to draw. And I'm actually going to name my points. If you drew your square, you should also name your points. Those are called your vertices. The corners are called vertices. I'm going to name this one as 515. This one is 510. This one is 1015. And this one is 1010. Now that's just my square. You guys can draw any size square that you want. And if anybody has a question, please ask me right now. Now, Roman, you should be writing on page 2, Roman. you should be writing on page 2. Angela, you should be holding your pencil and writing on page 2. That's what I want you to do right now. And please, Angela, turn off your mute so you're unmuted. Declan, you do the same. Hannah, you do the same. Aaron, you do the same. Turn off your mute.
My mom doesn't have that kind of sheet.
Oh, you don't have the sheet? That's okay. Why don't you just draw a square on your own paper?
Okay.
And if you drew the square, please name your points the way I named mine. Remember, the elevator goes first, and then you go up to the floor. Go ahead, Roman, do you have a question? Amelia, you have a question.
I
Amelia, what was your question, honey?
You like my square?
No, Amelia, I don't like it. I love your square. I love your square. That's the
just
coolest. It's a beautiful square. Now, who wants to show me their square? Just hold it up to the screen, Brennan. Everybody do it. Hold your square up. Oh man, Jeremy's, yours is awesome. Aaron's, yours is so cool. Brennan, you rock. Who else? Oh, Aiden's got a beautiful one. Hannah, awesome. Signe, wow. Guys, Signe even drew the diagonals. Can you guys draw the diagonals of that square? That's so cool. I want to draw my diagonals. I'm going to do that right now, Signe. You gave me a great idea. And
Just adding more diagonals.
I'm even going to make a right angle symbol in the middle because I know that all square diagonals form right angles.
Oh, good.
All right. Now, who can draw a rectangle that is not a square? The next one is a rectangle that is not a square. Go ahead, Roman. That was beautiful, by the way. Really, really nice. And Raymond, I can't see you anymore. So I don't know if you can make that happen. Nice, Raymond. Raymond, can I see yours, buddy? Can I see your square? Oh, wow. Beautiful. Now, guys, would you like to see the craziest rectangle ever? You guys want to see the craziest rectangle ever?
Yeah.
What do you think about that?
That's pretty large.
Is that the craziest rectangle ever? Now, can I see
Only
your
if we can't make
rectangle?
it
Amelia,
crazier.
let's start with you.
Again. And do you like the little squares I put in my square?
I love them. They are, do you know what those are called, Amelia? Those are called concentric squares. When you draw squares inside of squares that have the same center, they're called concentric. Now,
You want to draw that, huh?
I do. Now, I want to ask another question. Can anybody draw a rhombus for me? And remember, I want you to draw a non-square rhombus. A non-square rhombus. Remember, it has to have 4 equal sides. So I'm going to draw one, and I want to see if you guys can draw one also.
Okay.
Oh, nice, Signe. Signe, not only did you draw a beautiful rhombus, but you actually inscribed it in a circle, which was very cool. Declan, that was awesome. Truly awesome. And I would love to see your rhombuses. Please show me. Brennan? Oh, Brennan. Now, Brennan, you created a rhombus that was a square. Can you create a rhombus that is not a square, where the angles are not right angled? Oh, Roman, you rock, man. That's a perfect rhombus. Jeremy, can I see yours? And Angela, can I see yours?
La 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 la.
Oh, wait, don't do the la la thing because then everybody has to hear that. Oh, that's nice, Amelia. Angela, can I see yours? Oh, Aiden, that's perfect. Aaron, what about yours? Aaron, did you do yours? And Angela, I don't see yours, Angela, because you haven't held it up. Would you please show me yours, honey?
My mom said it was a bit easy for me, but I think this class is a bit hard because I don't understand much.
Okay, so the rhombus, honey, is 4 sides that are of equal length, which means that if you look at the size from one point to the next, they are of equal size. So if you pick up your pencil and you try to sketch it, it might work really well for you. So you want to make these sides all the same. You might even use your finger to measure it to make sure that they're all the same.
I still don't understand, but I'm very good at art.
What did you say about art, honey?
I'm very good at art and shapes.
Well, you're going to learn a lot more, and I hope that you practice. And if you try to draw it, I bet you'll do a really good job. But if you sit there and you don't try, it's really hard to learn. So that's all I'm going to say. I would love for you to try. Oh, beautiful. Now, who is going to try to make Mr. Kramer's favorite shape? Now, what is my favorite shape?
I already made a kite.
I want everybody to create a kite right now. Now, I'm going to let you look at this for just another minute, and then I'm going to go to the other page. So I want you to create a kite, and I'm thinking that I would like to make a kite, and I'm going to start all the way up here. No, that's a little funny. I think I like that one. How far down should I go?
So far into your rhombus.
I'm going to go right into my rhombus, and that is my kite. Now, to check to see if my kite works, could I draw diagonals? Can you guys help me draw diagonals from one vertex to another? And if you draw diagonals from one vertex to another, you are going to get a right angle, but only if you made it right. Amelia? Oh, Signe, yours is beautiful.
Look.
Hold it a little closer, Amelia. Oh, Amelia, that is very, very nice. Jeremy's. Oh, guys, check out what Jeremy did. Jeremy didn't just make a kite, but he also showed that the top ones were the same and the bottom ones were the same. Remember, they can't be all the same like a rhombus, but 2 of them have to be the same and the other 2 have to be the same to make a kite. Nice job, Aiden. Nice job. Very, very nice. Now, oh, let me see, Roman.
Mine's is like a rail kite.
Yeah. Now, guys, I'm going to ask you to go to another page. Can you go to page 7 right now, please? Everybody go to page 7. Now, and if everybody could please unmute themselves, I'd appreciate it. If you could. So I muted all, and now I need to unmute. How do I do that? ask to unmute. So everybody should be unmuted now. And
Mr. Kramer,
yes,
so how do you tell if it's page 7? Is it the top one here?
yes, that's the,
Or
well,
is it the bottom?
oh, you know what, sweetheart? You're right. Page 7 is the one where I named all the points. Now, everybody look at that crazy dot. Do you guys see that every single point has something in common? What can you tell me about every single point that I named? 0, 20, 10, 25, 15, 25, 20, 15, 30, 15, 35, 0, 20, 0, 10, 5. Who notices something interesting about this? I'd like to know.
It's all times of 5.
What do you mean 10 plus 5?
The timetable of 5.
Oh, and Declan, what do you recognize? What do you notice?
Nothing.
I'm sorry?
I said nothing.
Well, okay, you raise your hand, so that's why I call on you. Jeremy, what about you?
They all have a 0.
Well, do you see a 0 in that group of points?
No.
Or that group of points? Or this group of points? So you're very observant in that most of the points do have a 0 in it. And Hannah, what do you notice?
All of them are like triangles.
Oh, they all look like triangles. And Roman, what do you notice?
They all have 5s.
You know what, guys? They are all the counting numbers of 5. Can everybody do that? Give me your hands. Go. 5, 10,
10,
15,
15, 20, 25,
30,
35,
40, 45, 50.
Now, everybody stop right there. Now, guys, who can tell me how many sides, and I'm going to go to page 6 now, how many sides has this polygon? And I don't want anybody to call it out. I want everybody to count in the way that works really well for them. But please don't call it out. Just raise your hand when you think you have the answer.
Well, something happened.
Hey, it looks like Pikachu now.
It does look like that a little bit.
It looks like Pikachu from Pokemon.
So I have, now Signe, can you raise your hand electronically so you don't have to hold up your hand? I've already got Jeremy's hand up and I want everybody to count. I've got Brennan's hand up, but I want everybody to keep counting. Raymond raised his hand, leave your hand up. Everybody should be thinking about how many I have. Declan. All right, guys. Everybody tell me how many sides this polygon has on 3. 1, 2, 3.
25.
20,
19.
11.
Now, I've heard a lot of different numbers. I heard 11, I heard 25, I heard 19, and I heard 20. Would you guys like to see how Mr. Kramer counts? Watch this. I start by putting a little mark on one of them. And that way I can go what I call clockwise around it and count like that. Are you guys ready? Let's do it. 1, 2, 3, 4,
4, 5,
6,
6, 7, 8, 9,
9,
10,
10,
11,
11,
12, 13,
13,
14,
14,
15, 16, 17, 18, 19.
And guess what, guys? This has 19 sides. So we could call it a 19-gon, or we can call it a non-decagon. Everybody say that.
Non-deca.
Non-decagon, which is 19 sides. Now, everybody go to page 8. And I want you to make the craziest polygon you can. And you can go and make them as big or as small as you want. But remember, you cannot cross your lines. Every line, and if you have a ruler, it works really well.
You have a ruler. I have a ruler. What do
And after you create your polygon, I would love it if you would also count your sides. Now, I have no idea what my polygon is going to create, but I'm kind of excited to think about it.
Coordinates that are multiples of what? Determine what?
something.
And I always like to make the biggest polygon I can.
No. Now that is a huge.
It looks
And
like a
then
human riding a
sometimes-
spaceship.
What's
Looks
that?
Looks like a human riding a spaceship.
You know, I see something too. I see kind of like a duck with a fish jumping out of the water. And that's what I see. But you may see a
It
spaceship.
looks like a fox, like trying to eat the. It's like
Wow.
a fox trying to eat
Cool.
the birdie.
Yeah. And Brendan, what do you see?
I can't see your screen, so.
Oh, does anybody else have that problem?
No.
I'm gonna share again, so maybe this is gonna be helpful to you. Is that better, Brennan?
Yes.
Okay, great. I'm so happy. I'm so happy. Now, everybody look at me in the eyes right now. Everybody look at me in the eyes. Who is gonna make the most beautiful polygon and count their sides? Who's gonna do it? Raise your hand. Now, if you create one, send it to me. But one of the really cool things to do is to name each point. So for instance, this point right here is 2025. And you could name every single point, and that would be awesome. Now, I want you guys to say goodbye to your friends and say, I'm going to try to make the most beautiful polygon, and I can't wait to see yours.
Bye.
Say, I can't wait to see your polygon.
Bye.
Roman, that's so cool. Amelia,
Bye.
that's awesome. Raymond and Declan, Hannah. Bye, guys.
Have a ruler.
Oh, that's beautiful, Amelia.
Bye.